Hello guys, and welcome to another part in my DIY analog synthesizer circuit building tutorials. And this is part 2 to covering the ins and, well, it's not so much the ins and outs, but just kind of what I did with my own Steiner Parker Synthicon voltage controlled filter circuit. As we can see here, we can see that there is the diode ladder, and we have the capacitors, 3 capacitors, which pretty much give you that tone. Now, if we have a look on the screen, this is a schematic that I've just kind of drawn up. I'm not too not too familiar with using software to draw up schematics. I kind of do it all by hand. It's a bit hard for me to try and learn new software, etc. I mean, this is not as complicated as trying to use something as Cubase, but even still, I found it quite useful actually. I'm using KiCad to draw this. For those who are familiar probably already know that. If we have a look here, this is the original, well, not the original Steiner Parker clone filter circuit, because this one, as we can see, is from the Arturia Mini Brute. Now the difference with my one and this one is there's quite a few differences actually. For instance, down here where we send the 2 emitters down to the minus voltage rail here, we can see that it says minus 12. That could be minus, I don't know, say you've got 15 volts plus minus 15 could be 15, which is in my case. I've omitted this JFET. Oh, this is actually, I don't think this is a JFET. This is just just a normal field effect transistor, which you would normally find as a metal can for through hole component. This is a J1111, because all these components here, they're numbered as we can see. We've got TS4148. This will be a 1N4148. These are all surface mount component reference numbers, etc. Labelings. And as we can see here, this is the resonance part of the circuit. Now this was modified and developed by Yves Usson, who has a DIY site, which I'm sure you all know, which is at usynth.net or .com. Please go check it out. Lots of useful text in there and information that he goes into a bit more detail than I can. He's a lot more. This guy's been doing it for years and years, and give you a hell of a lot more technical information than I can. So yeah, so if we have a look on the screen, then pretty much this is what I have used. I've pretty much used what I've got. I mean, where we have the 22k resistors, I have they are specified to be 20k. I mean, to be honest with you, 2k doesn't make hell of a difference. What we have here, where we have the 10k, this is the control voltage reject, and what this does is supposed to null out the modulation, the amplitude of the modulation which you send either via an envelope generator or a low frequency oscillator when we're modulating our envelope generator. So again, if we just go over to the resonance part, we can see I have on the the output stage, I have a TL072 dual op amp. You could use a LM358, you could use a JRC or RC4558. I wouldn't go for anything like a NE5532, to be honest with you. I'd use a normal JFET input op amp personally. If we look on here, there's the transistors that I've used are the 2N3904. Now what you have to try and do for these, if you look at the topology of this, a lot of things you will find in a lot of voltage controlled circuits is these two mirrored NPN transistors. I mean, if you look at a VCA design, you will see these two NPN, you will see a pair of NPN transistors back to back, emitters are linked. Same thing goes for the VCO as well. My VCO circuit, if you look at the VCO circuit, we've got, I think they call it a current mirror. Could be wrong. Somebody comment and say you're wrong on that one, but that's what I think it is. I've heard that term used quite a lot. As we can see here, we have the inputs. We have a high pass input, the band pass input with a capacitor, and up the top here somewhere I'm going to find the low pass. We can see where the low pass input is, which goes here, and this is a 2-pole filter. It's a 2-pole 12 decibel per octave resonant filter. So we get we can actually crank the, if we go to, which part of it, if we go over to the resonance trim potentiometer, which is an internal trimmer, you have as an internal trimmer, hence I've put T on that there. I've used a 220k. Now the mini brute's specification is 50k, as we can see on here. It's got 50k, but I've been trying to just basically put my own twist on this circuit and get it sounding how I like it. I kind of prefer my circuit to the mini brute, to be honest with you. Again, the mini brute VCF mini brute stroke micro brute calls for 1.5 nanofarad capacitors, and it has another one linked in series on all of this. It gives you 3 nanofarads, and I think the higher the capacitance values you have, the more harsher the actual cutoff slope will be, because you're going to be cutting out more of the higher frequencies. So I know this is some kind of technical calculation you can do to find out what your maximum cutoff, but as far as I'm concerned, I just want to get on with listening to the tone of it. I don't do things by calculations and maths, unfortunately. I'm not that technically savvy, to be honest with you. Just trying to do my best and work with what I've got from what I understand. I mean, it is helpful to understand how the circuits work, but I think as you start to slowly build things, get things wrong, you start to try and figure out things for yourself, and then you slowly learn how all the different parts interact and what's going on with what. Again, as I was saying, with these NPN transistors here, it's good to try and match them, because this will give you your volt per octave. This is where your volt per octave input, as we can see, KBD control voltage is the keyboard tracking control voltage needs to go. So try and get a matched pair for this. You can also again use a monolithic pair. There's quite a few versions of this. There's a guy called Ken Stone, if you're familiar with synth DIY, a guy called Ken Stone does a version of this particular filter, and as we can see, we have multiple inputs on the filter. So we have a low pass in, band pass, and the high pass. So I have all 3 inputs injected simultaneously, but one output on the switch, so we can switch between the different outputs. If I just try and bring the circuit board over without breaking anything, as we can see over here, that is the switch for the VCF1, and I have one down for the VCF2. So they're both multi-mode filters, although the SEM clone filter, which is VCF2, is state variable, which means we can kind of blend between going through to low pass to notch to high pass. On this one, I just have a straight switch I've incorporated to combine the low pass and high pass together to give you the notch filter out. Sorry, kind of wandering off on subject here. Again, these, you can use a general purpose NPN transistors, and this part here, I think some of the original circuits call for the 2N 222 or quadruple. I think it's 2N2222 NPN transistors. So you can find a matching pair of them, or like I said, you can try and go for a monolithic pair. Things like these capacitors, the input capacitors, again, you can kind of mess about with the values here, play about the values and see what works best for you. Even the values of the capacitors in the diode ladder, you can try and have a play about with different types of, I mean, I've used quite a few different materials, different material types for the capacitor. I've gone for the ceramic type. I've tried the tropical fish, the old school tropical fish capacitors, and then I've decided to stick with the polystyrene because they give a very, very, very nice high frequency of the resonance. Although this can be quite a squally resonance when you have the gain up very high, the resonance gain. I also have an input gain stage on this as well, so we can actually drive the filter, or we can sort of back that off so we hear more of the filter than the actual oscillators coming in. Because once we start piling in 3 VCOs with 3 simultaneous wave shapes, it does get a bit chaotic, to be honest with you. So yeah, and as we can see, I have, this is over here is our frequency cutoff pot. Again, you can kind of tinker around with the value of that. You may kind of want to go for something like 100k to start with, and same thing with the resonance, and just get it so you've got a nice range going backwards from fully clockwise to anti-clockwise, and you can hit all the sweet spots comfortably without having to do too much minor, very delicate adjustments, and then settle with that. And yeah, and that's about it, guys, to be honest with you. Okay, well, if you've got questions, please leave them in the comments. Give me a like and subscribe, and also, like I said, don't forget to check out usynth, YUSYNTH, usynth.net, or I think it is .com. Anyway, till next time, people, take it nice and easy.